So hello everybody and welcome back to a brand new video, and in this video I'll cover problem C, that was color the picture from round 810. Also, before we start with the problem, there has been a blog post that Div1E was copied from a well-known problem online, and Div2E was also available online, so the round might be unrated. So let me know what you think about that. And so now we can start with the problem. Let me open a new page. Yeah. So in the problem, we have been given a n cross m grid. So, right, something like this with n rows and m columns. Right, but as you know, a grid is. So we have n rows and m columns. Also, we have been given k colors, where each color can only fill up some cells. So we have been given an array of size k, a1, a2, a3, so on up to ak, where ai represents number of cells that can be filled using color I. So we have an n cross m grid, we have some k colors, and we have to fill the whole grid using some pattern, right? We have to fill the whole grid using some pattern. So the pattern is each cell must have at least three toroidal neighbors with same colors as itself, So that is the pattern. So we have to fill the whole grid using this pattern. So let's first see what this term means, that is toroidal neighbors, what this term means, right? So if you have some cell in a grid, let's say here, right, then it can have four neighbors: the left neighbor, the right neighbor, and the bottom neighbor. But as you can see, there is no top neighbor for this. So for this, we can travel across the grid, right? So toroidal neighbors are nothing. Toroidal neighbors are nothing but adjacent neighbors. And they can also be across the grid. So every cell will have four neighbors, right? So at least three of them should have the same color as the cell itself. That is, if I am, let's say, cell ij, then it has four neighbors. Then if my color is red, then at least three of my neighbors should have color red. That is, at least three of my neighbors should have color red. So that's the pattern. So now we know the problem. We have a n cross m grid, we have k colors, and we have a pattern that we want to fill the grid with, right? So before starting the solution, let's see how our final grid will look like, right? So if we will know our final grid, it will be easier for us to make a solution, right? So let's see how our final grid will look like. Our final grid. So I will make an example grid and we will start inserting the pattern into it. So let's say I color the following cell red, right? Then at least three of its neighbors should have the color red. So I will make this red, I will make this red, I will make this red, right? Now the following cell has three neighbors with the same color. Now let's move on to the following cell. It should also have three neighbors, right? So I will make this red and I will this red. Now the following cell also has three neighbors, right? So now let's move on to some other cell. Let's move on to the following cell. I will make this red and I will make this red, right? So if you keep repeating the same thing, you will make the complete two rows red, right? So if you see now, the following two rows satisfy the pattern, right? Now every cell in this has three neighbors with the same color. So the following pattern satisfy our constraints, right? So you can see the pattern, right? So we will have at least two rows of same colors. We can also add same row of color red, right? So it will also be the pattern. So we will at least have 2 rows or 2 columns of same color. So the pattern is we will have blocks of rows or columns with same color, and size of each block should be greater than equal to 2, right? Because if you make a single line block, let's say something like this, let's say you cover this whole into green, and let's say you make then a blue block here. Then as you can see here, the following block, the green block, the following cell has no 3 neighbors, right? So the size of the consecutive color blocks should be more than equal to 2, right? So that's how our final grid will look like. So our final grid will be something like this. So if this is my final grid, it will be made up of consecutive blocks. So something like this. First we'll have red, then we will have some color of pink, then we will have some color of green, right? If you fill this column wise, or you can have the same thing row wise, right? Or you can have the same thing row wise. So you can have like first rows are filled with pink, then rows are filled with red, and then rows are filled with, let's say, green, right? So that's how our final grid will look like. So now from the given array, we want to tell if the array can be filled, the grid can be filled in the following way or not, right? So now we want to construct a solution for this. This is how our final grid will look like. And now we want to construct a solution. I will only tell the solution for the column thing, right? Because you can like always swap n and m and do the same thing again. So I will only explain the problem for the following pattern, right? That is when we fill in the columns, right? So if you want to replicate a solution for the rows, you can just swap your n and m. You can just swap your n and m and do the same thing again, right? So so let's move on to the solution for the column thing. So we have n cross m grid, right? And each column has n cells. And we have m columns. Also we have k colors, right? So for every color, a1, a2, a3, so on up to ak. So for every color I will check how many columns can it fill, right? So if I have my color ai, how many columns can it fill? It can fill a1 over n columns. Similarly, a2 can fill a2 over n columns, right? So on. So for every color I will find how many columns can it fill. But if some color is filling only one column, that is, if for some color, let's say ai over n is equal to 1, right? That means it is covering only one column. Then it is useless, right? Because if any color is filling only one column, then it will not obey the pattern. So if some color is only filling one column, then that color is useless to us. So we will not count that color. So my total number of columns that I can fill, total columns that I can fill will be equal to how much? It will be equal to summation of ai over n, such that ai over n is not equal to 1, right? So that is how many columns that I can fill using the k colors. So how can we find a solution using this? So on the basis of that, we will break this into 2 cases, right? The first case is when total columns are less than, and the second case is when total columns are greater than or equal to m. Obviously, if total columns are less than m, then the answer is no, right? Then the answer is no, because we don't have enough colors to cover all the columns. But if we go into the second case where total columns are more than or equal to m, then we can further break this into 2 cases. So the 2 cases are when m is even, and the second case is when m is odd, right? So if m is even, the answer is always yes. But the same thing cannot be said for m is equal to odd. Why so? I will give you an example. Let's say you have 3 colors, 1, 2 and 3, right? It can fill color 1 can fill 2 columns, color 2 can fill 2 columns, color 3 can fill 2 columns. So if you think about a grid, that has 5 columns. So first of all, you can fill 2 columns with color 1, you can fill 2 columns with color 1. then you can fill 2 columns with color 2, then you can fill 2 columns with color 2. But as you can see here, you cannot fill the last column, right? Because you don't have any color left now. Because if you try to fill it with color 3, then you will have a single cell and it will not obey the pattern, right? So even if you have, like, you can fill 6 columns here, you can fill 6 columns here, and it is more than equal to 5, right? That is m. So it is more than equal to 5, but still you cannot fill in all columns, right? So for m is equal to odd, you have to make some special checks. So for m is equal to odd, you have to make some special checks, right? So we will further break this down. We will further break m is equal to odd into 2 cases. We will further break down m is odd into 2 cases, right? First case is when there is some color I, that can fill odd columns, right? For example, if you have a grid, and these are all odd, right? Number of columns are odd. Now you have some color I, right? That can fill odd columns. So if you use the color I, then it will fill some odd columns. Right? So these are odd. So the leftover columns, right, that are m dash will be equal to even, right? Because you are filling some odd columns out of some odd columns. So the leftover columns will be odd. So your leftover columns will be even. Sorry. So now your m dash is equal to even. So now you have made your m is equal to odd case into your m is equal to even case, right? So now your case is equal to where m is even, and the answer for this is always yes, right? So when m is equal to odd and there is some I that can fill odd columns, you can use that color to convert your m is equal to odd case to your m is equal to even case, and the answer for this is always yes, right? So if that is not the case, that is there is not any color that can fill odd columns. That means all colors are filling even columns. So now you have all colors, right? So every color is filling some even number of columns, and there is no color that is filling odd columns. So now you have your m is equal to odd. Sorry for that. So now you have your m is equal to odd, and now all the colors are filling even number of columns. So what can you do now? Obviously you have to use at least one color that will fill odd number of columns, right? Because sum of all the even numbers will be equal to even, and obviously you will never be able to fill the odd number of columns. So you have to use at least one color odd number of times, and that is if you have some color, let's say x, then I will not use this color x, I will use this color x minus 1 times. Obviously x is even here, so I will not use this color x times, I will use this color x minus 1 times, right? So I can insert this color x minus 1 times here, and then the leftover columns will be even again. So it will again convert to my m is equal to even case, right? So I will check if there is some x that I can use x minus 1 times. So if I use any color x minus 1 times, my total columns will also be total columns minus 1, right? Because first I was considering this x times, but now I can only use this x minus 1 times. So the number of columns that I can fill will also decrease by 1, right? So after this, if my total columns minus 1 is more than m, right, then the answer is yes. Otherwise the answer is no, right? So I hope you are able to understand why we are using total columns minus 1 here, right? Because we are using x minus 1 instead of x, right? So the number of columns that we can fill have gotten decreased by 1, right? So we will check if total columns minus 1 is more than equal to m or not. So if it is, the answer is yes. Otherwise the answer is no, right? So that is the complete solution. So I will summarize it once again so you can understand it better. So we will find total columns, that is equal to summation of, let me draw a line here. This is the solution. Total column, that is equal to summation of ai over n, where ai of n is not equal to 1, right? Then there are two cases. Total columns is less than m, and that is total columns are greater than equal to m. The answer for the following case is no. The answer for the following case is no. The answer for the following case will break into two cases, right? First case is when m is odd, m is even, and the second case is when m is odd. So if m is even, the answer is yes. If m is odd, it will again go into two cases, right? It will break into two cases. First, there is some color I that can color odd columns, then the answer for this is again yes, because it will ultimately convert to m is equal to even case, right? Because this case will ultimately convert into m is equal to even case. Similarly, if my number of all my colors are coloring even columns, then I will check if my total columns minus 1 is greater than equal to m, then the answer is yes. Otherwise the answer is no, right? So that will be, here I will write all colors fill even columns. So that will be the solution for the problem. And if you guys want to see the code for this, here is the code. So I'm keeping my total number of columns and rows. Here my calls and rows. If I have to write it once again, calls and rows. Calls is equal to total number of columns, right? And my odd C, if I remove this now, my odd C is checking if there is some color, covering odd columns. And then I have OKC. I will check if there is some column that is more than equal to 3. Why I'm checking OKC? Why is this required if there is some column is more than equal to 3? Because in the last case, instead of using some column x times, instead of using some even column x times, you are using it x minus 1 times. But if all the columns are 2, if all the colors are filling 2 columns, then you can never use x minus 1, right? Then you can never use x minus 1, because x minus 1 will be equal to 1, and you can never fill one column. So you have to check OKC. So I'm keeping my OKC variable to check if there is some column that is more than equal to 3, right? So I can use x minus 1 in the last case, right? Because I have to use x minus 1 instead of x. So I'm keeping a OKC variable to check if there is some variable that is more than 2, right? That I can use x minus 1 instead of x in the last case. So that is why I'm using OKC. So here I'm counting all the columns, that is 𝐏𝐶, and that is vi over n. And if it is more than 1, I will add it to my total number of columns. And if 𝐏𝐶 is more than equal to 3, right? If it is more than equal to 3, then I will set my OKC equal to 1, right? I will set my OKC equal to 1. And if 𝐏𝐶 is odd, then I'll set my odd C equal to 1, right? Then this is my here. If column is more than equal to m, right? So currently I am in the following block. My total number of columns is more than equal to m, right? Sorry for this. So if it is more than equal to m and my m is odd, then the answer is, if my m is even, then the answer is yes. That is, if my m is even, then the answer is yes, right? Otherwise my m is odd, then I will check if there is some color that is filling odd number of columns. That is, if I will check if odd C is true or not. So then I will go into my if m is odd, and then I will check if there is some color that is coloring odd number of columns. If yes, that is I'm checking odd C here, then the answer is yes. Otherwise all the columns are coloring even number of columns. So then I will just use, if OKC, I will use columns minus minus, and if columns, that is column minus 1 is more than equal to m, then the answer is yes, right? Otherwise, if I'm not able to cover either all the columns or all the rows, then in the end my answer will be false. So that will be a complete solution. And if you guys have a doubt, feel free to join my Discord server, and I'll be more than happy to answer your doubts there. So see you guys in the next video. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is zero hidden fees, there is zero upfront fees, and they are granting you a minimum package of rupees 5 lakhs, and the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. You can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी कोडिंग आती नहीं है, मैं भी फ्रेशर, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long, and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below, and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.